In the name of Allah, the most gracious, the most merciful. Welcome to our discussion about the project presentation. I am Ghayth al-Saraqbi and my team consists of a number of students which are Ala, Turki, Muhammad and Abdul Salam. For me, I will take the design of slab S3. For Ala, he will take the design for beam B7, B8. For Turki, he will take the design of footing. For Muhammad, he will take the shear design. And for Abdul Salam, he will take the design of columns. So let's start. What is the target of this project? The target of our project is to design and construct a 125 meter square house in Fanatir district, Jubail Industrial City, according to the required structural specifications of ACI 318 and SPC 301 codes. We know that ACI stands for the American Institute and the SPC is the Saudi Building Code. So now we can go to the definition of house. What is the definition of house? Actually, the house is a single unit residential building which may range in complexity from a rudimentary hut to a complex structure of wood, masonry, concrete, or other materials, outfitted with plumbing, electrical and heating ventilations and air conditioning system. What is the scope of work for our project? Requirements, resources, processes, and all the design-related data are collected. AutoCAD software was utilized to achieve the structural and the architectural drawing. Analysis and design of structural elements of slabs, beams, columns, and foundations were done by using the standard design method, SDM. Cooperation, time management, outstanding skills, and the commitment of our team have made our work successful. Environmental aspects and the required safety procedures in the residential building have been taken into considerations. So now we can go to the plans. So this is the architectural plan of our house and this is the dimension plan. So, and this is the structural drawing. So what the structural drawing, what it helps us for? Structural drawing shows the placement of the columns as you will see here, C1, C2, C3, C4. So C stands for columns. So this is the placement of columns and the beam as you see here. For example, here we have the B7, B8. For example, here we have the beam B1, B2. And here we have the slab S1, we have the slab S2, and we have the slab S3. So this is the structural drawing for the residential building. So now we can go to the slab construction, a brief theory about the slab constructions. So what is the concrete slab? Concrete slab is a very common and important structural elements are constructed to provide flat, useful surfaces. It's a horizontal structural component with top and bottom surfaces parallel or near so. The concrete floor slab construction process include the erection of formwork. Erection, it means the creation of the formwork. Placement of reinforcements, pouring of concrete, compacting and finishing concrete, and lastly removal of formwork and the curing of the concrete slab. Now we can go to the loads and types of slab. What are the loads that can come to the slab? Actually, we have the dead loads, live loads, we can have snow loads in case of the roof, and we can have the earthquake load in case of earthquake. And what are the types of slab? Types of slab is the one-way slab and the two-way slab. And actually I put here a small figures for each one, for the one-way slab and for the two-way slab, to explain a little bit about the procedure. Actually, when we have a one-way slab, in what time we can call the slab as a one-way slab? Actually, if there is here Ly and Lx, Ly stands for the y direction. For example, here we have our slab. So this is the value of Ly, and here this is the value of Lx. Actually, when the value of Ly over Lx, this is the ratio, when the ratio is greater than 2, we can call it as a one-way slab. And when we have the ratio Ly over Lx is less than 2, so this one is the two-way slab. So I hope that it is clear for you. This is a brief theory, and actually this one you take it in the structural analysis, and here in the reinforced concrete this is like a brief theory about it. And this is the load distribution of the one-way and the two-way slab. As you know from the structural analysis, when you have a one-way slab, how the load distribution will be. Suppose that we have this slab, this is for our slab, and this is as a one-way slab. So if it is as a one-way slab, so you will divide it into like two pieces, like here. Half of the load will go to the right side, as you will see here, and half of the load will go to the left side. So this is the mechanism of the one-way slab. As you will see here in the picture, if you divide it like two, here he divided like that. So it is same. Half will go like this. This is the load, and half will go like that. So this is the mechanism of the load distribution for the one-way slab. And now we can go to the two-way slab. When we have the Ly over Lx is less than 2, so it is the two-way slab. But what is the theory behind it? Actually, the two-way slab, you will divide it into not into half like that. No, you will divide it into two trapezoidal, as you will see here. Trapezoidal. This one is number 1, and this one is number 2. This one is the second trapezoidal, and here like the triangle number 1 and the triangle number 2. Actually, for the two-way slab, the load transfer will go to the all ways. Will go to the right, will go up, will go down, and will go to the left. So when you have the two-way slab, the load will come to all the directions, from all the directions. But when you have a one-way slab, will go to the right or will go to the left. So I hope the brief theory is clear for you. So now we will go for the design of slab. Design of slab. Actually here I take the S3, which is here. This one I will show you here in the structural drawing. This is the slab that I take it now. So actually, the slab S3, we have like here discontinuous, and here discontinuous, and here discontinuous even, here discontinuous, and only this side is continuous. How we can know this side is continuous? Because as you see here, there is like a complete of the slab, as you will see. So this is continuous part, this is continuous part. But here it is discontinuous. There is nothing from here. There is nothing from here. So this one is only continuous, and the other part is discontinuous. Okay? So for the slab S3, we will start now for the design. First of all, check the type of the slab S3 as I showed you before. Is it one-way slab or two-way slab? So we have to find the ratio Ly over Lx. So what is the x direction? We have 4.5, and what is the y direction? We have as 10. So Ly over Lx we have 2.22, which is greater than 2. Therefore, you have to design it as one-way slab. So now we can find the total thickness of slab, h. This is the h. How you will find the h? Actually, the ACI code shows here values. You have to choose it. When we want to design at the ACI code, you have to go to this table. So actually, as I show you here, so it is one side continuous. Only one side is continuous, and this one discontinuous, discontinuous, discontinuous. Therefore, you have to choose the one end continuous. This one is h is equal to L over 24. So this one is h is equal to L over 24. So this is one end continuous. Therefore, you will choose this value. So when you substitute the values, you will get the h is equal to 7.5 inch. And actually, we have to round up to 0.5, because this one is difficult to make it in the construction. So you will go for rounding to 0.5, up to 0.5. So now we can calculate the effective depth. D is equal to the value of H which you calculated here minus 3 over 4. Actually we provide in the slab actually يعني approximately 3 over 4, which is 0.75 as a cover, minus half of the diameter. Actually in the slab we can use number 3 bar or we can use number 4 bar, but here in the calculation I choose number 4 bar. So what is the diameter of number 4 bar is 0.5. If you go to the data sheet you will see 0.5. Therefore you will substitute these values and you will get the value of D is 6.5 inches. So the first thing is you find H, the second thing is you find D. Now clear inshallah. After that you have to assume the width of the slab. So we can assume it as 12 inches. Now you can calculate the dead load of the slab by using the formula H over 12 into 150. 150 is the gamma concrete. So when you substitute the values, we will get the dead load is 93.75 PSF. Now we can calculate the live load which acts on the slab S3. Actually, here 40 PSF is specified from ACI code. When you have a residential building, actually we use the 40 PSF as a live load. So no need to calculate. Now we can go for the required area of steel reinforcement. So now we can calculate the ultimate load. So actually, what is the ultimate load? The ultimate load is the absolute maximum load that a structure can sustain without failing. So it is important to calculate the ultimate load. So how you calculate the ultimate load? By using the formula 1.2 into dead load plus 1.6 into live load. So we can get the ultimate load is equal to 176.5 PSF. Now we can calculate the ultimate moment. The ultimate moment is the maximum moment from the factored load, WL squared by 8. So you will get ultimate moment is 4.81 kilofit. And now we can calculate the value of Rn. What is the value of Rn? Rn is the concrete beam design ratio. So when you substitute the values, you will get the value of Rn is 126.50 psi. So actually, when you go to the table A13, now you have to find the value of rho. How you will find the value of rho? Based on this value. So 126.50. When you go here, 126.50 lies in the middle of this. So you can choose either the half of these values. I choose the half of this value, which is 0.00215. Take the average value. Therefore, 0.00215 is our value for rho. But actually, the ACI code specify the minimum. Rho minimum is as you see here. Rho minimum is 0.0033. So this is from ACI code, and this one is below 0.0033. Therefore, you cannot use it. You have to provide the minimum value from the ACI code. The ACI code here, as you see, specify a minimum value rho minimum for the rho. So you have to, if the value is less than 0.0033, you cannot take it. You will take this value, 0.0033. Therefore, use the rho 0.0033. Now use minimum percentage of reinforcement as I told you. Now calculate the area of reinforcement by using the formula AS is equal to rho into B into D. So rho minimum, B 12, D is 6.5. As we calculate, we get this value. AS is equal to 0.2574 inches square per feet. Now you have to find the value of AS. AS, how you'll find it? From the table A6. If we can go to the table A6, this is the table A6. We get the value 0.2574. So actually we can round it up. We can round it up to 0.26, right? So 0.26 is the bar number 3. So bar number 3. Okay. طيب, after that, what is the spacing of the reinforcement? See the corresponding one to 0.26, which is 5. Therefore, as you will see here, use number 3 bar with the spacing of 5 inch center to center, as I showed to you in the table. Now you can calculate the shrinkage reinforcement, which is the support reinforcement. This is the main reinforcement, and this is the support reinforcement. By using the formula, AS is equal to 0.0018 into B into H. So when you substitute the values, you will get AS is equal to 0.162. The same thing as we mentioned before. You will go to the table, 0.16. You will see that 0.16 lies between these two. You can round it up to 0.17, no problem. So when you round up to 0.17, you will get 8. So what you will write, bar number 3, this one is bar number 3, at 8 inch, right? 8 inch. So when you go here, you will see that use number 3 bar with a spacing of 8 inch center to center. So round it up 0.17. So actually now we can go to see the cross section of the slab S3. For the cross section, here we have the value of D 6.5, and here is the value of 7.5, and here is the total distance of LX. This is the LX value. 4.5 meter. When you convert it, it's 14.76 feet. And this is the reinforcement details. Here is number 3 at 6 inches, and here number 4 at 6 inches. I hope that this recording is helpful for you, and inshallah you will see the complete report for our students. Thank you very much.